Flux is a simple architecture. It's actually kind of a subset of an older architecture called MVC. And it's an architecture that lets us separate our concerns. It lets us separate our data from our view, from the things that operate on our data. It lets us keep things in independent sections so that later when we come to modify them, we know where things are. If people come to debug this later, they can find the data and they can find the view. And if there's a problem in the view, they can fix it. If there's a problem in the data, they can fix it. And this is a Flux architecture. So I'm going to start out in the simplest way possible. I'm just going to make a folder like so. And then we're going to open this folder in VS Code. And here we are. Right now, the first thing we want to do is to make an HTML file. Now we call this indexed HTML. That's because in the olden days, a web server would use a file system to back it. So the index file would be the index of a particular folder. I can just type HTML and then use auto completion to fill it in. And HTML has got two parts. It's got a head, it's got a body. The head is where the information about the page goes, and the body is where the page itself goes. Put some text aside of this, and we'll right click, and this will open this in the browser. And here we are. Now I might want to add some style to this. So I'm going to include a style sheet. Here we are. We're going to call this styles.css. Here it is. New file. We'll call it styles.css. And here it is. Now we can style everything inside the body if I want to, or I can style just a portion of this. I'm going to put this in an H1 here. And let's style all the H1s. Use the H1 selector here. Color it. Let's just go for blue. I've got to press refresh because I don't have any automatic refreshing configured. Now I want to add some JavaScript. So we can do this with a script tag. Now when JavaScript was new, you would put JavaScript directly onto the page like so. So I could, for example, do document.write and then write anything I want. Now as the document will be passed, going from top to bottom, this piece of script here would be run. If you press refresh, you can see this has been written onto the page. This is the original way we used to write JavaScript. As the HTML file was passed, you get down and you'd reach a piece of JavaScript and it would be executed right there and then in line. Because what I'm going to do now is I'm going to extract this into a separate file. Here, let's just make a file. This is a source attribute. I'm going to call it index.js. Inside of this, we'll put our document.write like so. And you can see I've now separated this. And if we press refresh, you get the same thing happening. Okay, now I want you to notice what I've done here. I've created this tiny little application in 3 files. One's the HTML, one's the CSS, and one's the JavaScript. I've separated those. Why have I separated these into 3 different parts? We call this separation of concerns. When this was new, we used to just pile everything into a single file. You'd put all your styles at the top. In fact, you'd put them in line with color attributes and things like that in the olden days, and width attributes on things here, there, and everywhere, and use tables for layout. And then gradually we realized that if you did that, you ended up with this massive sort of kludgy ball of everything all together. So we came up with this notion of separation of concerns, separating things one from the other. So you can see that in the HTML file, we have the structure of the page. We call it the semantics, the meaning of the page. In the CSS, we have the style of the page. And in the JS file, we have the behavior of the page. These are 3 different ways in which we can separate our concerns. Now, in the modern day, these are not the only way in which we can separate our concerns. We use patterns. We use things like Flux, or we use MVC, or we use some other design pattern. But keeping our concerns separate like this allows us to be able to find things much easier. If we keep everything together in a big pile, you can imagine how that gets very messy very quickly. So this is separation of concerns, cutting things into pieces so that one thing is responsible for one thing. And this is actually one of the principles of Solid, which we'll get to later, the principle of single responsibility. One thing does one thing. It's a coding practice that if we adhere to, we will generate nicer code that's smaller and tighter and critically later when someone comes to look at our code to try and understand it, to try and fix a bug, for example, they can find where we put things because they'll understand that pattern and they'll be able to follow it. So let's look at our JavaScript file now. You can see this is doing really nothing at all. It's just writing something to the page, and it's doing it in line. The HTML is being rendered. It hits this point here, and it just writes it in at that point. It's executed at that location, which sort of makes sense here. And we just write the words hello there into the document, which is a little application. This does actually work, and this is an application that we could build, and this is the sort of thing that we would do before. You might, for example, write the current date or something, or the current time, or if it was the afternoon, you might say good afternoon, or if it was the morning, you might say good morning. But we want to extend this. So what I'm going to do now is I'm going to take this and I'm going to start to create a little application. We're going to make an application that makes a list of something, and because this is my show, we're going to make a list of cats because, you know, hey. And we're going to do this using a design pattern called Flux. It's a pattern that we can find over and over in multiple applications. In fact, most applications, most front-end applications that you work on these days will use this pattern. The idea behind Flux is that you have a data store. The data store contains all of your data. Then you have a view, and the view sits over the top of the data like this. It really sort of wraps itself around the data. So when you change the structure of the data underneath, the view wrapping around it has a different shape. This is actually Facebook's introductory documentation to the Flux pattern. You can see there are 4 parts to it. We have our store. We have a view. The view here is the view on the store. And this is just a dumb view here. The view just shows whatever is in the store. Then we have this object called a dispatcher just here. The dispatcher is going to update our store. And then we have this notion of an action. So an action is something that the view can pass to the dispatcher to update the store. Now, I don't know about you, but I kind of really hate this. I find these sorts of diagrams really dry. I like to think about this in terms of an analogy. Let's draw a Flux architecture now. So we start out with a model. This is our model down here, and inside of our model we have a bunch of stuff, and I'm just going to put some triangles in here. There we are. Let's put a cat in there as well. Yeah. And what we're going to have here now is our view. So our view sits on top of the model here. And the view is like, I think of it like a tarpaulin, like a sheet. The view simply conforms to it. It doesn't really do any logic, it doesn't do any processing. It just takes the current shape of the model and it conforms to it. Let's add another cat to this. So for example, if I was to add a new cat here, slightly lumpy looking cat, I think he looks slightly angry. And then if I was to redraw my view, he sits over it differently. Yeah, this is a bad graphic. But you can see how when you update your model, it changes the view. So how do we update the model? Well, we have this thing called a dispatcher. Here's the dispatcher over here. I'm going to do the dispatcher as a little guy. And he's got a new cat. And he's going to stick it in to the view, like so. Here's our dispatcher. So the dispatcher's job is to add stuff to the model. And then the view's job is to faithfully render the model. It just wraps itself around the model. It conforms itself to the model and renders it on the page. As far as the user is concerned, the view is the application. But as far as we're concerned as the developer, the application is the model underneath and the dispatcher changing the model. So what about actions? Where do they come from? Well, the user is interacting with this view up here. Here's our user. He's sat on top. I'm just going to draw him there. He's sat on top like so. And he's got his keyboard and he's got his laptop there. He's pretty happy because it's a good application. He would like to add another cat to this model. He doesn't know there's a model there or anything like that. He just wants to add another cat to the view. So what he's going to do is he's going to compose a message to the dispatcher. We call this an action. He sends this over. He clicks a button. Maybe there's a button on the top here that adds a new value to the model or deletes the value or updates the value. He clicks the button. The button then composes an action inside of the view. And then this action then comes down to the dispatcher. And the dispatcher updates, takes that message, works out what he should do, if he should do anything at all. And then if he is supposed to do something, he then takes that, updates the model, he re-renders the view. And as far as the user is concerned, he's clicked a button and the view is updated. And this is Flux. This is the whole of Flux. In Flux, every time you change the model, you re-render the whole view, or effectively you do. In practice, you don't actually re-render the whole thing because that would be slow, but you re-render every part of it that's changed, and sometimes you check to see which parts have changed. This is what React gives us. It reduces the number of re-renders we do, and also things like Angular as well can do this also. It can reduce the number of changes to the DOM that need to be made. So we're going to start making this now. The first thing that we're going to need is a model. So let's make a model here. I'm going to call it the model. Yeah. And I'm just going to make an object. You see this? These two curly braces here are an empty object in JavaScript. And we'll look at this more later when we do this series about JavaScript, the beautiful language. So let's put some cats in this model. I'm doing this as an attribute. Here we are. Let's give our cats some names. Name, Derry the cat. Age 11. Make a couple more. And here we have a model. You can see a simple model here containing all of these cats. And we could put other things inside of here as well. If this was Facebook, this would be a news feed. It might have information about the current user. But you can see it's just a JSON object. It's plain, it's just data. Now I want to make something that can render this. So I'm going to make a view. Here we are. And again, I'm going to do this as an object. It doesn't need to be anything fancy. I don't need a class here or anything like that. I'm going to give this a render function here. In Java or C, we would call this a method. In JavaScript, it's just a function because functions and methods are the same thing in JavaScript. So in this render function, I'm going to first of all get hold of a div. This is going to be a div that I'm going to write inside of. I'm going to call this root. Yeah. And this is going to find an element on the page that has the ID of root. To make this work, I have to add an element on here that has that ID. So let's take out this hello here, and we'll just replace this with an empty div. Like so. Now I'm going to use my model to create my view. So let's make a list. Now this is iterative development here. You can see that I've output a simple DOM, and then I'm going to make it more complicated. So I've just put this in and hard coded it. Next, I'd like to take actually the list of cats here and output those. So we can do this very simply. If we just get the model.cats, I can just dip these directly into the DOM just like so. Let's view this. You can see we get object, which is not very helpful. Let's map this here. You can see here now we've got a list of all the cats here, but they're not in list items yet. So we can put them in list items just using backtick. And this is kind of ugly, I know. We'll tidy all this up in a minute. You can see this comes in. We've got these commas in between. The reason we've got the commas is because we're actually outputting an array here. And when you convert an array into a string, you end up with commas between it. So we can just join these together with an empty string just here. And refresh this. And then we have a list of all our cats. Very nice. Now, I don't know about you, but I find this quite hard to read on one line like this. I'm just going to convert this into multi-lines. And here we go. Now we have a list of cats, which are output. See, there's a model here. There's a view here that can render this model. And I'm just calling render at the end there to jam it on the page. Now, what can we see from this? Well, we can see a couple of things. One, I've separated my model from my view. My data is in one place, and then the view on the data is the other place. What does this mean? Well, the true application is the data. It's the data that we care about. The data is the truth of the thing underneath the hood. This data could come from a server, or it could come from wherever, but this is the true application. The thing that the user sees, the list that you're looking at here, is really just some sugar on the top of it. This is to make it nice for the user to use, but we as developers know that the actual application exists underneath the hood. We can view this application if we want to. If we come over here, I can open this up in my console. Let's just open up a console here, and I'm gonna look at my model here, and there it is. There's my data object, like so, with cats inside of it. You can see there they are. Zoom in a little bit so you can see the individual cats. This is the true application that we're looking at right here. And this thing here is the sugar. This is the skin over the top of it that lets us, that lets the user interpret the data that's underneath. And in theory, of course, I can now change this view to anything I like. If I wanted to create another view that was an API endpoint, for example, or was an iPhone application, or was some sort of other view, maybe an application for a watch or a smart TV or something that would fit into a narrow screen space, I can do that. All I have to do is change the change the view. I don't have to change the application underneath it. And of course, if I change my data, I can update the view to match it. Let's just take this model here. .cats .push, and I'm going to push a new cat into this array here. I've added another cat, and now if I want to show this cat, I can view.render, and here we have a new cat inside of the array. If I want to remove a cat, I can do that as well. Let's just filter out every cat with a name. It's not equal to Terry. You can see my model.cats. No longer contains Terry. Something happened to Terry. Terry died, I think. We view.render it, and you can see it updates here. It's very simple. I mean, this is obviously stupid. This is a stupid application, but you see how it fits together. You see how we have the data in one place, we have the view in a separate place, and we separate these two. We keep these two independent one from another so that we know later when we want to go and fix this. If it's a problem with the display, we can fix it in the view. If it's a problem with the data, we can fix it in the model. If we want to see what's inside the model, what the current state of the application is, we can do that very easily. We can just look inside the model and find out exactly what the state of the application is right now. There's no moving stuff from place to place. If everything is all in together, you end up with what's called spaghetti code. This is where things call themselves in loops. And if you end up with spaghetti code, you'll find that you'll very quickly end up having to change a little piece here, and this little piece here has to change this little piece over here, and this piece has to change this little piece over here, and you end up calling methods on methods on methods to keep everything up to date. And then when you add a new feature, you have to integrate that into this ball of code. Whereas if you keep these two separate, you've got a tree. You've got your data, and then you've got your view. Your data updates, you change your data, you press the button, and bang, your view updates as well. This is how React works. So if you're storing your data in state or in MobX or in Redux, your data updates, and then React will re-render, and then your view will just update automatically, just as we've got here, albeit in a much smaller form. The next step is to allow our user to update the view. what I'm going to do here is I'm going to allow the user to delete one of these cats. So let's stick a button in. Here's our button. You can see each of our cats has now got a delete next to it. So I can add an onClick attribute directly into this. OnClick is a valid attribute of a button. You can see there's lowercase here. In React, this would be onClick with a capital C. In HTML, this is onClick with a lowercase c because HTML is case insensitive, whereas the DOM itself is case sensitive, which is why we have a capital C. Let's put something into here. Okay, you can see this is iterative development here. I'm just building this up stage by stage. If I come back over here and press refresh, now if I press one of these delete buttons, we get the word cats inside of here. I don't want to do that though. I'm going to do something a little bit more interesting. So what I could do inside of here is I could modify the model and call re-render. Let's do this to start with and just see what it looks like, and you'll see how quickly start to see how bad this looks. I'm going to filter out cat such that cat dot name dot triple equals to re-render the view in order to update it, and you can see here, and then we need to assign this back to model.cats. I don't even want to continue with this because it works. Sort of. And this is bad code, right? I don't even want to look at this. Why is this bad code? This is bad code because, well, A, there's flipping tons of it. Look at all of this inside of here. It can't even fit into a single line. But more importantly, this model here, this button now knows about everything. This button here is calling the model directly. It's updating the model. Then it's assigning values to the model. It's and then it's re-rendering the entire view. And if you remember the principle of single responsibility, one thing does one thing. Our view shouldn't be rendering itself. It shouldn't be updating secret objects which are inside the model. It's outside its purview. The job of the view is to render the data. That's what it does. It doesn't update the data. It doesn't change the data. It doesn't render itself. It doesn't loop around on itself. This is the beginnings here of spaghetti code. So I don't want to do this. Instead, what we're going to do is break this out into a thing that in Flux we call a dispatcher. I'm going to take this out of here all together, like so. And we're going to say instead dispatcher.dispatch. And then we're going to send it an action. Now I'm writing this in Redux style here. If you were to do this in MobX, you'd actually find this was very considerably simpler. And actually, I really like MobX. I use MobX professionally. I would encourage you to look at it. But I'm going to do it in Redux style because that's the standard at the moment. So I'm going to create an action like so. It's a delete action here. And let's give it the name of the cat. Here we are. So I've now put this on a new line here. You can have as many new lines as you like, and it's just nicer. So now this is going to call this object here called dispatcher. It's going to send it this object here containing an action of delete, and it's going to give it the cat's name that we want to delete. Now I'm assuming here that the cats are unique, that they don't have duplicate names. That might not be a safe assumption. You'd probably want to use an ID or something like this if this was something for real. So we would need to create this object called a dispatcher now. Let's make one here. And it's going to receive an action. Right, now, let's do something depending on what the action is. So I'm going to just use an if statement here. We might want to change this into a case statement later. But since I've only got one action, it's pretty simple. We'll call this action.type equals delete. Then this is now going to update our model. I can now paste in the code that we had earlier. Here it is. And we don't need all of this craziness around it anymore. Now this is going to modify the underlying data. And all we need to do now is render the view. You can see how I can add in as many actions as I like here. So I can add in an action to add a new cat if I wanted to, or to modify a cat if I passed in different values using a form. Here we are. So when I do this, it's going to call dispatcher.dispatch. It's going to pass through the type of delete. It's going to pass through the cat's name, and then we're going to filter the cats here, and then we're going to render the view. Press refresh, and there we have it. So we've separated this into three things here. We've got our model, which stores our data. We've got our view, which shows our data here. And then we have our dispatcher here, and the job of the dispatcher is to update the model and then render the view again. One data object, one view on that data object, and one thing that then changes the data object, passes it back through to the view. And this is Flux. This is the essence of Flux. This is all that Flux is. We've built a whole Flux pattern here in a single section of code. Yeah. I'm Nick Johnson, and this is Senior Dev Time. When I started in this industry about 20 years ago, everything was quite simple. We had this new language called JavaScript. We had CSS, which was quite small. We had HTML, which was, again, quite small. I had this very gentle ride up. I got to learn things little by little as they were created. And I'm conscious that it's not the same for people these days. You're expected to jump in and really learn everything all at once. And that's difficult because you don't have the historical context. Most of the things that we've built have been built in the context of what went before. For example, a fat arrow function. Fat arrow function has a static value of this, but you might ask the question, why? Where does that come from? What's the backing for that? Why do we even have this issue in the first place? And actually, it makes complete sense in the historical context of JavaScript and where it came from. We're going to be looking at basic coding principles, things like solid, for example, things that are used over and over that you can pick up and you can see in code that you will come across. Thanks for watching. I hope it's been useful. In the next episode, we'll be talking about closure, which is a topic that confuses a lot of people, but is actually really easy once you understand it. In fact, you're probably already using it already. So we'll be looking at 3 places where you're probably likely already using closure. If there's a topic you'd like to see covered, leave a comment below. As always, there's a GitHub link in the description if you'd like to download the code. If you'd like to see more videos like this, please feel free to subscribe and also hit the bell button if you'd like to have notifications.